This video will discuss the final validation obstacle, number 6, of project activity definition for project developers who aim for successful VCS validation. Project activities or interventions are defined by VCS as a specific set of technologies, measures, and/or outcomes that alter the conditions identified in the baseline scenario and which result in greenhouse gas emission reductions or removals. The VCS allows a project to expand via multiple temporal instances as a group project until spatial boundaries become fixed at first verification, rather than just one individual project. VCS does not, however, allow a vague expansion claim, such as growing through the entire country. Rather, specific eligibility criteria for a combination of project activities and geographic areas for group instances must be defined in validation per VCS standard section 3.6.16. Methodologies for each project activity will define which of these 6 potential carbon pools, sometimes called SSRs, stocks, sources, and reservoirs, may be included in accounting. An issue I've seen with some projects is trying to include a pool in the project accounting but not in the baseline, which is not allowed. Note as well that some of these SSRs are poorly defined in the literature. The one SSR well-defined, above-ground live tree biomass, depends more crucially on the allometric equation selection choice than the measurement SOPs in the field. Another issue I have seen is trying to convert timber volume to biomass with expansion factors. Allometric equations are almost always preferred when available. An expansion factor, for example, should only expand the biomass of the stump and the crown, maybe a 20 to 30% addition. Biomass is often crudely converted to carbon by multiplying by 0.5, an equation that may be improved in the future. Carbon is then multiplied by 3.67 based on molecular weight to get carbon dioxide equivalent. These 3 baselines show the project activities I will discuss of RED, declining baseline, IFM, improving baseline, and ARR, a static baseline. WRC, wetland restoration conservation, is a 4th project activity type I will discuss at the end. This table summarizes my data from a 2017 paper reviewing all VCS validated and verified projects globally at that time, 70. I analyzed audit impact in terms of reduction of ex-ante estimated to ex-post realized offsets, and also thoroughness in terms of hours spent in the audit. All projects were thorough in terms of spending more audit time on larger offset claims. However, in terms of impact, auditing had the least impact on RED projects, though new remote sensing tools may improve this result. There was no correlation between number of findings and thoroughness, as auditors could be lumpers with a few major findings or splitters with many minor findings. This table also shows some of the quantitative results of my research. Note that avoided deforestation projects are an order of magnitude larger in terms of hectares than other project types, followed by IFM and then ARR. In terms of offset quantities, the ranking is reversed, with ARR first and avoided deforestation last. However, all project types, despite wide ranges, had surprisingly similar verified offset medians around 3 tons of CO2e per hectare per year. This is not a lot of income with carbon offset prices of $10 US. Note that some AR plantations of fast-growing native species, such as this acacia grass, could achieve higher offsets, but these higher offsets will be temporary as growth plateaus. Average lifetime offsets for these fast-growing species would likely not exceed 6 tons of CO2e per hectare per year. Leakage is also called displacement, secondary effects, slippage, and spillover. There are 3 types of leakage, including activity shifting, such as cattle ranchers moving their cattle out of the project area into an adjacent area, market, such as other timber properties, increasing their harvest to meet demand from reduced harvest in a project, and ecological, such as plantations reducing groundwater and thereby growth of nearby naturally regenerated stands. Leakage may be positive or negative, though only negative activity shifting and market leakage are often required to be accounted in VCS methodologies. Leakage also has spatial boundaries, defined as leakage belts for monitoring and management zones for circumvention. Leakage. Although I found a median of 0 for leakage deductions, I suspect these deductions are higher today, particularly with IFM projects for market leakage. Impermanence buffers are called non-permanence, non-achievement, durability, and reversal risks. Although standards frequently require buffer set-asides, VCS also allows a portion of these buffers to be released and sold as the project proves its permanence over time. Median impermanence buffers in my research ranged from 10 to 21%, with the leakage range the highest with IFM. Note that buffers may need to be increased in the future to account for climate change impacts on forest, from weather conditions of increased magnitude, severity, and extent, fire, water, and wind. One avoided deforestation involves using the term REDD+ instead of REDD. The UNFCCC definition of REDD+ is reducing emissions from deforestation and degradation, plus the role of conservation, sustainable management of forests, and enhancement of forest carbon stocks in developing countries. REDD+ therefore can refer to a wide range of forest carbon activities, including AR in terms of forest stock enhancement and IFM in terms of sustainable management. On the other hand, REDD is the only, without the plus, is the only means reducing emissions from deforestation and degradation, and can be subdivided into sectors such as APD, avoided planned deforestation, and AUDD, avoided unplanned deforestation and degradation. VCS defines deforestation as the direct human-induced conversion of forest to non-forest land. Forests may be defined country by country, with a wide range from 0.5 to 1 hectare minimum and 10 to 30% forest cover. Degradation involves the persistent reduction of carbon stocks that does not result in conversion, such as partial logging, either legal or illegal. Methodologies differ in whether they cover both deforestation and degradation is particularly difficult to monitor through satellite imagery. Avoided planned degradation, such as legally logged to protected forest, LTPF, is classified by the VCS as IFM, as it involves forest to forest. There are 3 remaining issues with REDD. First, proponents should use free satellite tools such as Global Forest Watch to identify project areas above the global deforestation rate of 0.5% per year. Otherwise, proponents stand little chance of reducing rates if their project area already has average rates of loss. The next issue is that REDD project activities must be carefully chosen to directly counteract the deforestation drivers acting in that region of the world. This graph shows 10-year tropical deforestation rates globally and corresponding driver contributions. Building rural hospitals and schools may be worthy charitable projects, but don't have direct impacts on deforestation rates. In this next image, a region of the Amazon in Brazil, pasture and agriculture clearing are the drivers and correspond to a herringbone pattern related to frontier road building. Intensifying established cropping and grazing and closing existing roads would be 2 potentially efficacious project activities in this area. Note as well that an important element of REDD is conditionality of tying payments to performance based on deforestation metrics over time. IFM is defined by VCS as activities that change forest management practices to increase carbon stocks on lands legally managed for wood products. In addition to LTPF, these activities include reduced impact logging or RIL, extension of rotation age ERA, and low productivity to high productivity LTHP. One issue here is that VCS per sections 3.2.2829 caps offset quantities at a long-term average LTA for either IFM or AR projects with harvesting. Harvesting being defined by the VCS as reducing carbon stocks by 20% or more over a 5-year period, starting with the first reduction instance. Another issue is baseline establishment with IFM. A conservative practice is to set the baseline at the initial level of carbon stocks at inception. Dynamic baselines should be matched for forest type and age, distance from road and mills, and ownership class of corporations, charities, families, or government. Afforestation covers land that has not been forested for 50 years, whereas reforestation covers land that has been forested for 10 to 50 years prior. Revegetation covers land that has never been forested, such as chaparral. Per VCS standard 3.927-28, proponents may not introduce either non-native monocultured or invasive species, such as this eucalyptus, in Kenya. Enrichment activities of planting in gaps in established forest are not covered under VCS ARR definitions either, and present additionality obstacles, as well as slow rates of growth from enrichment due to limited growing space. Another obstacle for ARR is multi-species polycultures. Feng et al. Has identified complementarity in terms of increased growth rates with two species of polycultures with different leaf morphologies of broadleaf versus needleleaf, and also different lifespans of seasonal versus evergreen. However, there's little data for polycultures of more than two species on relevant management practices and historical growth to accurately predict offsets. Using naturally regenerated mature forest biomass equations for polyculture plantations is not appropriate. ARR provides some of the clearest additionality, provided that the project's carbon offset purpose is documented prior to planting. However, reforestation involves high upfront costs and also delayed benefits. Costs of tree planting outside of land purchase is estimated at $1,500 per hectare in Costa Rica and Panama, and there are annual costs for weeding during the critical first decade of growth. Furthermore, ex-post offsets cannot be sold until year 5 when the trees are sufficiently tall to achieve breast height and thus store measurable carbon to undergo a verification audit. Finally, let's discuss blue carbon of WRC, wetland restoration conservation. One obstacle here is that white, black, and red mangroves require saltwater communication to various extents, but engineering is required to manage this communication so as not to wash away the saplings from waves and high tides. Another obstacle is that although mangrove ecosystems may provide substantial below-ground carbon storage, this storage is expensive and difficult to measure. Autochthonous carbon inputs in the soil must be distinguished from allochthonous. Note that projects with peat soils will need to choose an applicable methodology.